We have some functions that are undefined at particular locations. And when we say undefined, there is no value. Sometimes we say does not exist, abbreviated does not exist. These happen a lot with fractions. So let's just recall a little bit about fractions. If I have 0 over any number, such as 0 over 2, that's equal to 0. If I was to show that through division, 0 is divided by some number, 0 times n equals 0. So that exists. If we flip this over and say n over 0, that is not equal to 0. In other words, if I redo this and I have n is divided by 0, what number times 0 is n? There isn't such a number because anything times 0 is 0. So this is a case where it does not exist. There is no value for that. You can also ask yourself, this really says the word no. No, you can't do that. So let's practice function notation and also identify these places where I might have an issue with a fraction. Those occur a lot. Function notation, this says x position needs to be a 2 in my function called f, 1 over 2. X needs to become a 1 in my function, 1 over 1, which reduces. F needs to become 0 in my x input position, and that's the case where we get does not exist. In the last one, f becomes negative 1 input for x, and I get negative 1. Now the graph of this is going to be a little difficult to see. If I plot 2, my input was 2, I get an output of 1/2. I'm going to show that relation. When I put in 1, I get out 1. When I plugged in this 0, I got this does not exist, and we'll show how that appears on a graph. And here, when I plug in negative 1, I get out negative 1. So let's plot the ordered pair 2 and 1/2. And then the next ordered pair is 1, 1, and negative 1, negative 1. If you look, if I plug in a value that's closer, such as f at 1/2, I get 1 over 1/2, which means 1 divided by 1/2. Dividing fractions turns into 2. So this is going to grow and keep growing, and so I'm going to get this little loop, and it's going to follow the axes, and likewise that's what happens here. Now this idea of when x is 0 does not exist, here's where x is 0. So what we do is we show it by this dashed line, knowing that there is no value there for x. So my graph will never get to the y-axis, which happens when x is 0. Let's try a couple more. In my function for x goes 2, simplifying. Into my function goes 1. Those fractions all appear to be okay. Does the 0 appear to be okay when I put 0 in? Yes, it does. But as soon as I put in that negative 1, now I have 1 over 0, which does not exist. Graphing that again is a little difficult. So we're just going to worry right now about what values in my input, x, or domain will not work. So in this case, negative 1 is not in the domain. It cannot be an input value in 1 over x plus 1. Let's try a third example. Now I have a numerator that's 4. That's never going to change value. Simplifying, negative 1 and negative 2 is negative 3. Putting a 0 in, looks like 4 over negative 2. Oh, I can simplify that. Putting a 1 into my rule, 4 over negative 1 is negative 4. And now 4 over 2 minus 2 is 4 over 0. So that's my does not exist. So we say the domain does not include, the important does not include the value 2, because as soon as I put 2 in this position, I get a 0. So what's the easiest way to tell if you're going to have a problem? Well, first of all, if you have a fraction, with a variable in the denominator, you're going to have a problem. And the problem is when my denominator is equal to 0. And in this case, that's going to happen when x is negative 2. So you only look at your denominator for problems, and those happen when they're equal to 0. So if you solve that, you will find the area in which you have a problem or does not exist.